Hello, in this project we are using a lattice beam and block, or what we call rib beam and block, for the decking of this particular project. So in this video I will just be talking you through the lattice girder. So in the girder you will have the top bar, the bottom bars, and the lattice itself. As you can see, you have the rebar, which is at the bottom, and also you have the top bar, which will normally bond with the concrete topping once you've done all your beam and block. And finally also the lattice, which actually serves as the shear force. So what we have done is that we went into one of the engineering markets where we purchased this kind of plates as per the specification from the structure engineer. And we have all our drawings, and in that drawing we were able to manufacture the, the molds as per the structure engineer specification. So these were all welded and then conveyed to the site. I would say you need a structure engineer, qualified structure engineer, to do the design for you. And from there you can then do your molds and take them to the site. And in this case, we apply anti-rust, and that will allow these molds to last very, very long. So in doing all of this, we've saved a lot of costs, because this is not the conventional way of, of decking buildings. This is the rib system, which is actually pretty much straightforward, economical, much more lean system of working, and the technology is highly advanced. So in the site you can see that we have applied anti-rust onto these molds. So we left them to dry for a couple of hours, and by so doing we also went ahead to bring in more molds, which came later, and those we also applied anti-rust to them later on as the project progresses. Yeah, these molds are easy to make once you find a welder. These are very easy to make. With the dimensions, you take them into the machine, and the machine will then do the design straight away. It's not difficult. What we then went on is to purchase the 12 millimeter iron rods, and these were all specified in the engineering drawing, which is the structure drawing itself for this particular type of project. These are the lattice, you call them, or the rings. So the steel engineer, or the steel technician, I would call him, the steel technician, started doing all the lattice. We chose this method because we prefer to use a specific type of binding wires to do this job here. There is also another version where you use the zigzag or the diagonal bars for this. In that one you have to weld, you have to adopt welding. You have to weld this to the top bars and the bottom bars. But then we chose this method. It is also lattice. They are used throughout the world, very strong. Once you have a highly skilled steel technician, they can do this for you. So these are the products. Once they are done as per the drawing, there's still a technician did all this, we purchased 1 ton of, initially we purchased 1 ton of 12 millimeter iron rod and also several quantities of 10 millimeter. And then later on we purchased another 1 ton. So in total we used 2 tons of 12 millimeter iron rods and then 10 millimeter iron rods. That's what we used. So after his work, the steel technician, as you can see, he went ahead to use his magnetic instrument to pick up all the remnants. These are all the pieces of iron rods or binding wire, which he then picked all of these from the side. And what we needed next is an 8 millimeter quarry chippings. For this you have to use 8 millimeter. Okay, 8 millimeter, which is 338, I think, that's what was specified in the drawing. With your ratio of aggregate, that's aggregate, the mixture, everything specified by the structural engineer. So that's what they've used here, and you can see this is exactly what's going on. Once the concrete is mixed, all of this transferred into the mold, and these are the masons. Let me say, there's the mason and his workers on this, and they began to install the girders. So this is the casting stage, and this is what you will say these are precast. Precast, basically. We used some kind of engine oil in the mold. That's oil, just to allow, and this enabled them to demold the beams. And these are the results. You can see they came out very nice, straight and solid. Yes, so they did really good job. Yeah, the key thing is to get your mold straight. That means you need a welder who can do all the dimensions, and then you take them to the machine, or he takes them to the machine, and the machine molds will do all the molding and everything. So here we have the iron rods. All of these are ready, and the mason and his workers, they did a good job to do the precast. So as I said, to do this type of work you need a drawing from the structural engineer, and then you can proceed with your work. It is a lean, or let me use it that way, a clean way of decking. You don't need tons and tons of wood and bamboos and all sorts. On this, all you need is the mold. You can decide to use a wooden mold. For that, you need a carpenter who can just make the mold for you, and you can easily use wood also. Now, the trouble with wood is that, concrete needs water. So when you use wood, you might end up losing some water, but not that much. But if you use, let's say, metal plates, the water will stay inside the concrete, and that is what will give you its extra strength. So you can cast the dimensions in the design. You will see that there are different dimensions or length of beams. So if you have long molds, you can just cast different dimensions inside the mold. So we have something like a dividers. So once you do your dimension, you just divide or block the mold as per the beam that you are casting, the dimension you are casting. So it is not difficult. It is not demanding. You don't need a lot of labor, very, very minimal labor. You don't need a lot of skilled labor. All you need is a mason who will do the aggregate. And in this case, it is easy to control. The quality control here is very, very high because the mason is able to wait for these to dry, demold them, and then cure them. Just so the curing is 21 days for this. So every day we water these beams. Yeah, so it's easy. The quality control here is very high, and everything is standard, and they are all marked also. So when it comes to installing them on the building, they are very easy. They are not that heavy. These are not T-beams. T-beams are different. They are much more heavier. But as I said, these are just rib beams, or what we call the lattice girders. So they are, depending on the length, they can also be slightly heavy, but there are techniques the installers use to just put them onto the building, on top of the roofing when it comes to the installation. So, as I said, you don't need highly skilled people. You don't need a lot of labor because naturally it doesn't demand a lot of labor. Yes, because you have to cast, wait for these to settle, dry, demold, put them to the side, and then do it again. You have to go, come back maybe in 2 days. This is what they did, because if you wait, you can demold them the next day, but if you wait 72 hours, that means you can get them. They will just come out easily, very, very easily, yeah, without any trouble. Yeah. So that's the mason pouring water. This is done daily, except for 21 days, plus. And concrete in itself, precast in itself needs water. So the more you add water, the stronger the beams will be. Each time you try doing new casting, you just clean the mold, apply engine oil, and then you go ahead and then do your mixture, your concrete mixture, and pour your mixture in there. Make sure you vibrate the concrete. Either you use some kind of tool, hammer, to hit beneath the mold to settle. In some cases, you can use a vibrating tool, but as long as you have like a hammer, a mallet, just hit under so that the concrete can settle and vibrate, so all the air bubbles can disappear. In that case, you should be fine. These are not difficult. You can, as I said, this project, we've saved a lot of money on this. Yes. The mold, probably will say, is the mold which cost a little bit, not a lot of money, but the individual is going to use it for several projects. So if you look at it, the operational cost is very good, because this is not the only project the owner has. The owner has several projects. So structurally, yes, he will have the mold for a very, very long time to use on other projects. So If you have a one-off project, then fine, you can adopt the traditional system. It will cost you. But as I said, instead of using the metal mold, you can just use a wooden mold. And that makes more sense. When you use a wooden mold, you will save a lot of money. Your beams will also be strong, So this can be done. The key thing is to ask a structural engineer to give your plan to a structural engineer, and they will then draw the this lattice, the installation, the bending schedule, everything for you. And based on that, you just make your mold, find a carpenter, make your mold out of wood. You can. And when it comes to the block, there will be a next video on the type of block that we will use. Yes, so that's another part of the video that will come later. The type of block. The key thing is that here the blocks are always hollow, so they allow for services, thermal insulation, and also with this type of, let's say, decking, it's a light one. The roof, there is light because the blocks are hollow, so that reduces the weight on the building itself. You are not using a lot of iron rods like the traditional or conventional way of decking your building. That is a heavy form of build. You have to create all those formworks to do that. But here, it is not that. You need, in this type of decking, you need some props, bamboos, or maybe steel bars to do your propping, and then you are good to go. Yes. So it doesn't require a highly skilled person. As long as you have one person who is very skilled, they can lead the rest. And with the help of your structural engineer and the steel artisan, you can just do this on site. There is also another way where all of this can be done on the building. The precast, everything can be done. But in that case, you need a lot of wood, and then, but that demands a lot of wood. Yes, but in this case, here, the only thing you have to do is find individuals, few people who can lift the beams. It is not a macho or a muscle. No, it's just slight technique. And then they'll put the beams on top of the building, set the hollow blocks in them, and then it works. So yeah, these beams have not been installed yet, because we are in the process of making the mold for the block itself. And once the mold is ready, we take it to the machine, we'll get the blocks, and from there we will deck this building, and that will be really beautiful. Yes. So anyway, it is not difficult, as I said. If you have all your engineering drawing and you have somebody like a mason who is serious, they look on the plan and then they will cast everything. Because in that drawing, all the length, everything, the installation, it's all in there. So he can also do few on-site measurements, test and adjust, and then from there he will cast the beams, precast them for you on site, and you save a lot of money. The biggest savings here is wood. Wood is very expensive in Ghana, highly expensive in Ghana. Yeah. So in this particular video, you will not see a lot of wood here. No, no. Everything that comes onto this site gets consumed. You'll be surprised. The amount of cement you use, it's not that many. Yes, because it's precast. There's a ratio, So yeah, thank you very much for watching this video. If you like it, please share this video and give it a like. This is a new channel, and as I said, there are several projects, and hopefully we'll get to post a lot of videos for you. So thank you very much.